Right, what are we on? Question 13. So, 1 minus 3x to the power 5. Okay, what are we doing? We're expanding this and ascending powers of x up to and including the x squared term. So, right, so this is a binomial expansion question. So, I want ascending powers of x. So I want this to the power 0 to begin with. So I'm going to have 5 choose 0, minus 3x to the power 0, 1 to the power 5, plus 5 choose 1, minus 3x to the power 1, 1 to the power 4, plus 5 choose 2, minus 3x to the power 2, 1 to the power 3, plus dot dot dot. That's me done, isn't it? Right, so now I just need to work out these coefficients. So that's going to be 1 to the power 0 is 1, so I just get a 1 for that. Right, next one, I've got a 5 choose 1, which is just 5. And then I've got a minus 3 to the power 1, which is minus 3, so that's 15 times 1. And the power on the x is a 1. And then this one, I've got 5 choose 2, which is 10. Yeah, 10 times, well, I've got minus 3 squared, which is 9, so that's plus 90x squared, and then plus dot dot dot. Just be really careful. It said ascending powers of x, so it wanted the x powers to be going up. Right, now what does it want? An approximate value for 0.97 to the power 5. Right, look, I want this thing to the power 5. Why don't I make this thing to the power 5 equal this thing to the power 5? And that's going to tell me what value of x I should stick into my approximation. So I get 1 equals 0.97 plus 3x. So I get 0.03 equals 3x. So I get 0.01 equals x. So if I stick in 0.01 to here, I should get an approximation for 0.97, which is 0.859, which hopefully is an approximation for, well, let's have a look. I mean, you can always check. I'm doing 0.97 to the power 5, which is 0.8587. So that's looking like a pretty good approximation. If you've got something completely off, you might want to just have a think. Oh no, there's a part C. State with a reason whether your approximation is greater or smaller than the true value. Right, look at this expansion. The next thing, the next term, would be this to the power of an odd power, to the power of 3, which means that the next thing I'm going to do is I'm going to take something away from this. Admittedly then, the next thing I'll do is add something on. But the thing that I add will be smaller than the thing that I've taken away. Yeah, because the power will be greater, and when I put a number in, like 0.01 to the power 5 is much smaller than 0.01 to the power 4. So I'm going to take something away, and then I'm going to add something which is smaller than the thing that I've taken away. So I am going to stay less than this number, so this number must be greater than the true value. Okay, so I want you to just have a think about that. This number is greater. The next term in the expansion would be negative, yeah? So you would be taking something away. Admittedly then you would add something, but the thing you add would be much smaller than the thing that you've taken away. So if I did the next term and then stuck in 0.01, I'm going to be taking something away from this. So this must be bigger than the answer. Wow, I waffle quite a lot about that question there. I don't even know if that made sense. Let me know if that didn't make sense. Hopefully that did. You're taking something away, and then you're going to add something which is smaller than the thing you took away. So this number, we're never going to be able to get bigger than this number, and in fact, we are going to get smaller. This number must be bigger than the actual answer. Right, what are we doing? Question 14. Shall I turn over? All decisions. Question 14, I'll have a read first. Right, what have we got? We've got square root of x minus x squared minus 1 over x squared. Sorry about that. Root x minus x squared minus 1 over x squared. And I'm showing that f of x can be written like that, where c is a constant. Right, you'll notice that this is f dashed x. So we're going to be integrating in order to get f of x. But before I integrate, there's no way on earth I'm going to integrate it when it looks like this. I'm going to have to rewrite this in a nicer way before I integrate. So I'll probably write that as a power half to begin with. And then I can write it as x to the half over x squared minus x squared over x squared minus 1 over x squared. I can split up my fraction like that. Right, now when I'm dividing, I subtract the powers. So that's x to the power 3 over 2. That's 1. And that's x to the power of minus 2. Right, now I'm going to integrate this. So f of x is the integral of f dashed x. And remember, this dx just means that x is the letter that I'm dealing with. So I need to integrate this thing, I think. Right, let's have a go. So, increase the power, and then divide by the new power. Increase the power, divide by the new power. Plus c, don't forget your plus c. Right, I'm going to be really naughty and go there instead. So, I'm going to get minus 2x to the minus a half, because I'm dividing by minus a half. So that's going to be minus 2, minus x, and then I'm dividing this thing by minus 1. So that's going to be plus x to the minus 1 plus c. And then you look at how it wants the answer. Oh, and that's a bit of a pain. Right, well, let's have a look. So, I'm going to write this as what I've got. I've got minus 2 over root x minus x plus 1 over x plus c. Now, if you look, they want this written as a fraction with a common denominator of x. So I'm going to try and rewrite all of these things with a common denominator of x. In order to get an x on the bottom here, I need to multiply this by a root x. So I also need to multiply the top by a root x. I've kind of rationalised the denominator. In order to have an x on the bottom of this thing, at the minute it's got a 1 on the bottom. So I've multiplied the bottom by x, so I multiply the top by x. And this thing already has an x on the bottom. So now I can put all of these things together. So minus 2 root x, oh dear, minus 2 root x minus x squared plus 1 all over x. And they've put the minus out the front. So they've got minus, and then they've taken the minus out, and they've taken a minus out, so they've had to turn that into a minus 1, like that. Sorry, that got very messy. And that is the same thing. They've just got their 2 root x and their x squared in the opposite order. But that's fine. Right. Find the value of c. Given that f of x goes through the point 3 minus 1. So we've got that f of x is minus x squared plus 2 root x minus 1 over x plus c. Now it goes through this point. So when I stick in x is 3, I need to get minus 1. So I get minus 1 equals minus 3 squared plus 2 root 3 minus 1 over 3 plus c. So I need to tidy this up, put it on the other side, and that's going to give me c. So I get minus 1 equals minus 9 plus 2 root 3 minus 1. Oh, I'm going to make that 8. Over 3 plus c. Put it on the other side. So I get 8 plus 2 root 3 over 3 plus 1 equals c. So I'm going to add that 1 onto that number. So I'm going to get, well, I'm going to write, I mean, you're probably picking up a calculator. I'm going to write that as 3 over 3, so that then, oh, it's a -1. Ah, this is a -1. I brought this onto this side, but that -1 is still going to be a minus. Well spotted. Right. So I wrote my -1 as 3 over 3, and now they're both over 3, so I can take it away. It wants me to write C in the form P plus Q root R. So I'm going to write it as 5 over 3 plus 2 over 3 root 3. Now I'm going to see if that's right. So I fudged. Yes, good. Fine. Okay. So what was the difficulties in that question? Oh, noticing that it was an F dash to start with, so that you had to integrate. Once you've done that, I don't actually think it was too bad. Right. Stick at it, folks. Last question. Oh, sorry, I just whacked the table. Question 15. Oh dear, it's a 16 marker. Never mind. Let's have a go. And then you don't have to listen to me dribbling on for any longer. Well done if you stuck at it this far. Right. Show that point A, which is 5, 1, lies on the circle. Find the centre and the radius of the circle. Right. What you're not going to write is 5 squared plus 1 squared minus 4 times 5 plus 6 times 1 equals 12. We don't know that it equals 12 yet, so let's find out that it equals 12. Right, so do not write 12. We're writing 5 squared plus 1 squared minus 4 times 5 plus 6 times 1, which is 25 plus 1 minus 20 plus 6, which is 26 minus 20, which is 6, plus 6, which is 12. So hence, 5, 1 lies on the circle. Good. What else does it want? It wants the centre and the radius. Right. Now we know that a circle, once it's in this form, is really easy to deal with. So let's put it in that form. Once it's in that form, then we can read off loads of stuff quite easily. So I've got x squared plus y squared minus 4x plus 6y equals 12. So I'm going to write that as x squared minus 4x plus y squared plus 6y. Put my x's together, put my y's together. Right, now I'm going to complete the square on each of these parts now. So I'm going to complete the square on that part. So I get x minus 2 squared, but then I need to remember to take away what I get when I do minus 2 times minus 2, which is 4. So I need to take away the 4. If that was a blur, look up completing the square. Okay? So that, when I expand x minus 2 times x minus 2, I get x squared minus 2x minus 2x plus 4, which is x squared minus 4x plus 4. Now I want x squared minus 4x, but I don't want the 4, so I have to get rid of it. That's where that's come from. Right, put the numbers then on the other side. Add on a 4, which is 16. Add on a 9. Oh, it's 25. It's a square number. Yay, good. Right, so what's the centre of the circle then? The centre is 2 minus 3. And the radius is 5. Once it's in that form, you can just read them off. And that was 5 marks, believe it or not. Right, B. Find the equation of the tangent to C at point A. What's A? Oh, A is 5, 1. So, find the equation of the tangent to C at the point A. Give your answer, blah, 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 blah. Right. I feel a picture coming on. So I've got a circle. Wow, that is not a circle. Anyway, and the centre is 2 minus 3. And I've got a point A, which is 5, 1. So like here or something. That's my point A. And I've got a tangent like that. Right. And I know that A is 5, 1. Right. tangent and radius are very much perpendicular. If you find the gradient of your radius and find the negative reciprocal, that will be the gradient of your tangent. I've got a point on the tangent. Happy days, let's go. So, let's find the gradient of the radius, which is going to be the difference in y's, so y1 minus y2, over the difference in x's, which is going to be minus 1 plus 3, which is 2. 5 minus 2 is 3. Right, the gradient of the radius is 2/3, I think. So, henceforth, the gradient of the tangent then is going to be the negative reciprocal of that. So, minus 3 over 2. Okay? Right, so, what have I got? This is my point. So, I've got y minus y1 equals mx minus x1. Again, you might now be doing y equals mx plus c. That's fine, that is not a problem. And what do we want? We want it in the form y equals mx plus c, where m and c are rational. 15 over 2, so I get y equals minus 3 over 2x plus 17 over 2. What a nasty looking answer. And it is completely wrong. Funny. Okay. Answers on a postcard. What have I done wrong? It's my centre, right? 2 minus 3. Yeah. Right, it must be my gradient that's wrong. Oh, that's not a minus 1, you numpty. That's just a 1. Ah, so that's a 4. So that's a 4. Oh, I'm so sorry. You might not have done that. That's a 4. That's a 4. That's a 4. So that's a 4. So that should be a 19. And that should be a 4. So you get y equals minus 3 over 4x plus 19 over 4. Oh my goodness. I can hear Xander shouting the right answer at me. Minus 3 over 4x plus 19 over 4. Wow. Well, I got as far as 15b before doing something terrible. That was just a 1, not a minus 1. Right, I'm all flustered for part C. I'm going to do part C. I was just thinking it had gone far too well. Right, y equals x squared minus 2 intersects the tangent at the points P and Q. Given that O is the origin, find as a fraction in its simplest form the area of POQ. What a random question. So what was it? It was y equals minus 3 over 4x plus 19 over 4. Possibly. Minus 3 over 4x plus 19 over 4. Yes. Right. I'm going to read that again. The curve, blah, 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 intersects the tangents at 2 points. Right. If 2 graphs intersect, that is equivalent to solving the equations simultaneously. If I solve these two simultaneously, I'm going to get the point where the graphs intersect. So I need to solve x squared minus 2 equals minus 3 over 4x plus 19 over 4. Was it minus 3 over 4? Yes. Right. I'm going to multiply through by 4. Those 4s that have been the bane of this question. I'm going to multiply through by 4. So I got 4x squared plus 3x minus 27 equals 0. Right, I need to solve that now. You're probably all using your quadratic solver, aren't you? But I don't really know how to do that. So I try it. Polynomial, degree 2. 4, 3, minus 27. Ah, okay. Solve it in whatever way you want. I've used a quadratic solver on the calculator. Right, so I've got those two values. Oh, that means it will factorise. What are my values then? 4x minus 9 and x plus 3. Is that right? 4x squared plus 12x minus 9. Yeah, you could have factorised it. Anyway, they're the two solutions. So what do I want now? Well, I need the corresponding y values, don't I? because I want, I'm trying to find the area of this triangle. So I need some y values probably so that I can maybe draw a picture. I think I'm going to find the y's. Right, it doesn't matter, does it, what equation I use to find the y's, because it's the point where they're intersecting each other, so it doesn't actually matter. I'm going to put it into the, I don't know, the quadratic one maybe? So that gives me 49 over 16. And then when I put in minus 3, I get 7. It's kind of hoping for some nicer numbers. Right. Let's draw a picture. So I've got the origin. I've got point P and point Q. So point P is 9 over 4 and then 49 over 16, which is just over 3. So I've got kind of just over 2 and just over 3. So that's 1 point. And then I've got Q, which is minus 3, 7. Okay. Right, so I've got a triangle which looks something like that. I just wonder if that's right-angled. Oh, I don't know what to do. I'm going to see if it's right-angled, I think. Yeah, I'm going to see if it's right-angled. So I'm going to do that length squared, and I'm going to add that length squared, and I'm going to see if I get that length squared. Actually, no, I'm just going to find the length of the 3 sides. That's what I'm going to do. Right, what's the length of this side? 3 squared plus 7 squared, square rooted. Right, I think that's root 58. What's the length of this side? 9 over 4 squared. I feel like I've lost the flow now. I feel like this is only going to go badly. Oh, no. Oh, I just don't know if this can be right. Can it? That just does not look good, does it? And what's this last one? Well, you'll all be having a good chuckle anyway if I've mucked this up monumentally. Is that right? Not like you can answer. Minus 3 minus 9 over 4 squared, and then 7 minus that squared. Okay. The question is this a right angle triangle? If I add that to 3697 over 256, I don't get a whole number. Okay, well, perplexing. Let's have a think. So, it's not right angled, but that's okay. Oh, there must be a better way of doing this. Oh, well, in an exam, if you can't see a better way, do anyway. I'm going to find that angle using the cosine rule. Oh, this can't be the best way of doing it. I'll keep thinking. Hopefully this shows that I am just doing it with you rather than, copying anything. Right. So, 3697 over 256 equals b squared plus c squared minus 2b c cos a. Right, bear with me. I will just work out what this turns out to be. Right, that's minus 693 over 8 equals 2 times 11025 over 256 times root 58. Okay, so right, so I wonder whether cos A equals 0.13. That makes A 82.4. Well, this will be a miracle. Let's see if this is the right answer. Okay. Right, so I get the area is half A B sine C. Now my worry is it wants a fraction and I just can't see that I'm going to get one. But in an exam, if you don't know what to do, you do something. So I'm doing something. Okay. I don't think that's the right answer. Oh, what am I doing here? Okay, I panicked and paused. Right. This was wrong. I did this too quickly. This was wrong. This should have been 0.866. So this method is correct. 0.866. And then I inverse cos, which should give you 29.9. If you put that in there, it comes out as 399 over 32, which is 12, and 15 over 32, which is the answer. Unfortunately, I didn't pause long enough to think of a better way. Right, let's go back to this picture. What are we missing on this picture? It's not right-angled. So what are we missing? Right, look. That is a right-angled triangle, and that is a right-angled triangle, and this whole shape is a trapezium. So we could do it like that. Why don't you try and do it like that? So area of a trapezium, A plus B times h over 2, where A and B are the parallel sides. We would have got it doing it this way. I tried to rush and not bore you with the typing into the calculator of this bit. But if you do this properly, you'll get that cos of A is 0.866. You get that A is 29.9, so that when you put 29.9 in here, it does turn out on the calculator to be a nice fraction. Well, what a catastrophic end to an otherwise successful hour and a bit. So, I hope they're really useful. Please have a go at that paper. I'll pop a note on Show My Homework to tell you what I'd like you to do with it. Anyway, I hope you're all well. Keep in touch. Bye.